Good day everyone. Today we're going to look at the second oscilloscope that I got for free from school back in the summertime. This is an Iwatsu model SS-5702 dual channel 20 MHz analog oscilloscope made in 1984. You may not have heard of Iwatsu before, I certainly never have, but they were apparently a fairly popular manufacturer of oscilloscopes, and they actually still are today. They are still making oscilloscopes today. And yeah, my school had a whole pallet of these, as well as a couple of Gold Star oscilloscopes, one of which I've got, and you can see the video of that on this channel. They had a whole pallet of these, like over a dozen of them. So I actually grabbed two of them in addition to a Gold Star. I gave the other one of these to my friend Brandon because he's been wanting an oscilloscope and he's been enjoying it. And back in September I actually filmed a video of us in the student development studio at school with his oscilloscope running some oscilloscope demos on it. Sound files that you feed into the oscilloscope to make it display really cool patterns. I will edit that video and show it someday. So this is a pretty cool analog oscilloscope, and let's prop it up on the foot on the bottom here so we can take a better look at it. This is pretty much a basic bare bones oscilloscope. This has all the basic features that you would expect in a full-size laboratory quality oscilloscope and nothing more. And in my opinion, that's just fine for an oscilloscope, especially if this were to be someone's first oscilloscope. I think this particular unit right here would be an excellent example for one's first oscilloscope. So once again, it's dual channel, 20 MHz, same as the Gold Star oscilloscope. So let's take a look at what we have here. First of all, it is a Crt Display, standard green phosphor, but it's got this blue filter over it, which can be removed by these 4 Phillips head screws here. I will remove it and show you what that looks like later. First, channel 1 controls. Your voltage range can go from 10 volts per division all the way to 5 millivolts per division. You get AC, DC, or ground coupling, BNC for the input, and the positioning knob. You also get 5 times magnification by pulling the knob out. Same for the channel 2 controls. For channel 2, you can also invert it though, which flips it vertically. This switch up here lets you choose to display either channel 1, channel 2, display both channels, or add the signals together. A feature which I talked up and demonstrated in the video of the Gold Star oscilloscope. Quite a unique and pretty cool feature. I think it's on most oscilloscopes, but I had never heard of it and I never knew what it did until I tried it after acquiring this scope and the other one. When you're in XY mode, which is the mode where it doesn't apply a time base, so there's just a stationary dot on the screen which is modulated by the signals being input into both channels, where one channel is the Y modulation and the other channel is the X modulation. The switch chooses which channel serves as the Y modulation. You get a ground terminal if you want to use it, the power switch as well as a power LED, the trace rotation, controls for intensity, focus, and scale. What is scale? Well, the scale, or graticule as its proper name is, actually has an incandescent backlight, and it's variable brightness, and that's what this knob controls. And the scale actually lights up red in color when it's lit up. That's a pretty neat feature. The Gold Star doesn't have that. Calibration terminal for a probe. It outputs a 0.3 volt square wave, 1 kilohertz probably. This is for an external trigger if you want to use it. This switch here for what the trigger source is, channel 1, channel 2, or the external. And when you're in XY mode, this switch controls which terminal serves as the X modulation. Coupling. AC, external, D, well it's just two positions. AC, which is also called external DC or TVV. Like the Gold Star video, I have no idea what this controls. I just set it to that and it does stuff it's supposed to. Same for sweep mode, auto or norm, no idea what it does. Trigger level, very useful. Our time base. In addition to the XY mode at the far counterclockwise, we get 0.2 seconds per division, all the way to 0.5 microseconds per division, 500 nanoseconds. Very nice. Horizontal positioning for the trace. The center control adjusts the length of the sweep, so if it can reach all the way across the display. But if I turn this control down, I know the camera's out of focus. I hate when this camera does that. When you turn this control down, it shortens the sweep length, and the time base actually adjusts accordingly, so it sweeps faster. And you can pull it out for 5 times magnification horizontally. There's an inner control on the time base as well. To vary the time base at its selected setting, it clicks at the far clockwise, and that's when it's in the calibrated mode, so you can go by these numbers. Same for the volts per division on each channel. There's an inner knob here to vary it, or back into the calibrated mode. And that's it for the front controls. A very nice scope. The controls are very well laid out. I very much like how this is laid out. Very easy to understand, even for the novice. On the left side, a vinyl handle. On the top, some remnants of its days as a university engineering lab oscilloscope. Its original lab identification number. And a sticker on here. UNB, Electrical Engineering Department, H117, which is the Digital Systems Lab, which I've had a couple of classes with labs in that room, including one this semester. So yeah, pretty neat. This came out of that lab, which I'm familiar with. The date it was sold, August 28th, 1984. Written right on there, very nice. Sold and serviced by Atelco. Don't know who they are, but they're in Scarborough, Ontario. On the back, we have a serial number. Iwatsu Electric Company Limited. Made in Japan. They are a Japanese company. Iwatsu certificate of something or other. And this does have adjustable line voltage input from 90 to 250 volts. 257 volts. And that is switched by this jumper block. If I pull this out, yeah, it does go in 2 separate positions. D or B on this scope. It was set to B because we're on 120 volts. To get A or D, or yeah, A or C, I don't know what you'd have to do. Maybe change to a different jumper block or something. Ah, yeah. Oh! Okay, you turn the jumper block, you turn it upside down, and now you can get C or A. Very nice. I will put that back to B. We get a fuse, AC line input, standard IEC cable, a Z-axis input. I think that controls, like, when it sweeps, or controls the time base somehow, or maybe just when it blanks. I'm really not sure. And another discrete ground terminal. Now, Iwatsu is still around. They're still making oscilloscopes as well as other lab equipment. And I took a look at past versions of their website and on the Internet Archive and found something very interesting. Iwatsu had to have been one of the last, if not the very last, oscilloscope manufacturer to make pure analog oscilloscopes. Pure standard analog oscilloscopes just like this one. Iwatsu maintained a full range of analog oscilloscopes up until 2012. Isn't that remarkable? Tektronix completely discontinued their analog oscilloscopes, completely discontinued the entire line in 1997. Iwatsu kept them rolling until 2012. That is remarkable. In late 2012, they thinned out the line to just 3 models, the 3 highest end models, which went up to 470 megahertz. And then they discontinued those last 3 models in either late 2013 or early 2014. Isn't that remarkable? They had to have been some of the last analog oscilloscopes ever manufactured. Purely analog. There's no digital. I'm talking oscilloscopes that had no programmability, no digital functions like an on-screen digital multimeter or anything. Pure old school analog oscilloscopes just like this one. They made until 2014 possibly. That is very remarkable. Today they make just digital oscilloscopes. Alright, let's open this up. To do so, there are 4 Phillips head screws. One there, one back there, and 2 more on this side. Back in a moment. Once the cover is off, this is what we have. Of course, the first thing you notice is a very large CRT, or very long CRT I should say, covered in a shield so we can't see who made it. Might have been Iwatsu themselves though. And the circuit board on the back there. So this isn't as well integrated as the Gold Star oscilloscope, but we are of course talking about something manufactured in 1984 as opposed to something made in 1994. There was a lot of advancements in integrated circuits made in those 10 years. We have 2 circuit boards, all the componentry. So let's take a look at each. On this one here, we've got some, what are those? Might be transistors D758. Those might be transistors. And the ones on the left here are green in color. That's kind of cool. We got some integrated circuits still. A couple of them are socketed. That's kind of nice. And let's see. Put you upside down here. They are made by Toshiba. These 2 here. TC4011BP. Okay, those are 4000 series CMOS ICs. And the date code on one of them is 51st week of 1983. And the other one is 38th week of 1983. This socketed chip is a... I don't know who manufactured it. There's an F logo. Could it be Fairchild? No, not in Korea. I'm not sure who that logo belongs to. But the chip is a 733 PC. I don't know what that is. First week of 1984, made in Korea. And notice also that everything's on this board is very well labeled. And there's even test points, you know, ground test points and test points for voltages and stuff. Also, there's a lot of glass packaged diodes in there. Let me see if I can... Unfortunately, the lighting in here's not very good, and I'm not filming this with my handy cam, which I left back at Mom's house, so I don't have a light to brighten things up. But I'll do the best I can. Oh, those glass packaged diodes. Very nice. This one's HA1127, I don't know what that is. 4A3, so 1983. We have some NEC, what I would assume, well, I was gonna say, I assume they're transistors, but, well, they're labeled Q, so that should be transistor, because Q is the common letter to use for transistors when referring to electronics. Also, notice a lot of bodge jobs done on this board. Some wires strung from places to another. Very interesting. And yeah, some NEC transistors. That one's a 461A. I assume they're transistors, but they got many legs on them. That one, I can't see good enough to see how many legs are on it, but it looks like it could be like 8 legs. And the other one's the same, NEC 461A. And check out these switch mechanisms. And the inner component controls this potentiometer. Alright, let's move to the other side. One of the integrated circuits in this is very interesting. You'll see why when I get to it. On the other side, we have a lot of the power supply circuitry. There's the transformer hiding back there. And a couple of fuses. Ooh, look at that big resistor. Isn't that neat? Green in color. It is 7 watts, 2.4 kiloohms. Big ceramic resistor. That's pretty cool. Some more of the rotary controls there. Made in Japan. H board K-K1774. This might have the horizontal circuitry on it. Is the other board called V board or something like that? I didn't bother to check. Doesn't say anything on it that references it as having the vertical circuitry. But this board's called H board. There's some interesting components back there. A little rectangular box made by TDK, interesting, and I have no idea what it is. The number on it's HVT-3D. That might be a flyback transformer for the CRT. It is under the danger high voltage section. It's probably a flyback transformer for the CRT. Oh, look at that, some neon lamps that serve the purpose probably that I mentioned in the Gold Star oscilloscopes video. Got some Toshiba, I don't know what those are. They're made of plastic. They might be transistors? Round plastic transistors? That's the first that I've seen. Toshiba 481. Oh, you know what? I think they're rectifiers because they have a negative and a positive molded into the casing. So that might be what those NEC parts are too. Okay, here's the really interesting IC. Take a look at this. Okay, it's a JRC, part number 4558D. I don't know what it is, but look at the manufacturing date. 35th week of 1998. So you know what that means. This thing actually died sometime back in the late 90s or early 2000s. And it was repaired. That's kind of cool. So that shows you right there that this thing was used and maintained and probably kept calibrated right up to the turn of the century, which is pretty nice. But yeah, I thought that was kind of cool. It gives a little insight into the history of this thing. It actually bit the dust in 1998 or thereabouts, and that IC was at fault and it was replaced, and now this thing's working great again. Very good. Got a TTL chip here, a Texas Instruments J3, no, that's not the part number, that's the date code. Part number is SN74LS74. So yeah, it's a 74LS74 TTL chip. Down here we have a CMOS chip, MSM 4011 RS, a 4011 CMOS chip. I can't, oh, Oki? OKI? Is that Oki data? It's a, oh, this stupid camera. It's a diamond with the letters OKI imprinted on it. I wonder if that's Oki, like the same company that had the Oki data brand of computer stuff. I don't know. Interesting date code, 42nd week of 1976. So evidently a new old stock chip that they just had lying around. And down here, a 74 LS04 TTL chip with a date code of 1984, looks like. So, I think that's, oh yeah, right there, if this thing focuses, there's a very beautiful glass packaged diode right in the center of the video. And I've taken a good picture of it, and I'll show it right now. Very nice. I like glass packaged diodes. They're very unique. So, there you go. And yeah, I covered all the ICs. So there's the inside of this thing. I will put it back together and we will demonstrate it. Alright, we're all plugged in and ready to go. I haven't prepared for this video by warming this thing up. This will be the first time I've turned it on in a couple of months. So let's do so. And because I haven't allowed it to warm up, the readings are going to be slightly inaccurate, but we can use our imaginations and pretend that everything is accurate. So the trace is coming up here, and looks very nice. Got a nice kind of teal color. The intensity gets plenty bright. And the scale lighting. And there you go, there's the scale lit up, and it lights up red. And incandescent bulbs. I think there's 3 of them up there. And the blue filter filters the light so it's not so yellow. That's also quite nice. So yeah, that's the dial light. Very nice. And, we can turn our time base down here. There's the XY mode. And I can crank the intensity up, but only for a second, because if you show a steady point and the intensity set too high, you can actually damage the phosphor at that point. So I'll do it just for a sec. And there you go, very bright point. And like I said in the video I made with Brandon playing with his oscilloscope, which is the same as this, you'll get to see it display a bunch of cool patterns using some oscilloscope demonstration audio waveforms that people have made. Alright, got my probe connected to channel 1. I'll touch it to the probe test terminal. And there you can see the square wave. The period is every division, just about. And I'm on 1 millisecond per division, so that would correspond to 1 kilohertz. If I turn it up here, you can clearly see it. If I turn the intensity up, you can see the vertical lines caused by the beam suddenly swinging up or down. So there is that. And if I touch it to my finger, you get a lot of interesting noise there. I turn the intensity up a bit. Kind of interesting. And that's 60 hertz noise being picked up by my flesh or whatever. Turn it down a bit so it doesn't flicker as much. It flickers a lot because 60 hertz is flickery, of course. Now it looks like this camera actually isn't showing the flicker too bad. It actually looks pretty good. You can see a little bit of motion there caused by the flickering. So yeah, there's that. And other than that, I'm not going to show too much because I've already shown a lot of stuff on the Gold Star oscilloscope video, and I'll be making a dedicated video of oscilloscope tests using an oscilloscope to measure neat real-world items that I've been interested to see what they look like on an oscilloscope. And of course there are many other videos on YouTube of people demonstrating measuring stuff on their own oscilloscopes. So that's all I'm going to show of the Iwatsu SS-5702 20 megahertz dual channel oscilloscope from 1984. This is a pretty darn awesome oscilloscope. One thing about it I haven't mentioned is that it's very small and light for a full-size lab oscilloscope. In fact, the manual for this oscilloscope, which you can get online, Iwatsu called it one of the smallest, lightest oscilloscopes of its time, and is indeed way smaller and way lighter than my Gold Star oscilloscope. And yeah, all around it's a really cool oscilloscope. It seems to be built well, and you know, it's got everything you'd need in a basic oscilloscope, and it's just very, very nice. It works really well. I just thought of something I forgot to do. Show this hood taken off. So just 4 Phillips head screws. I'll do that right quick and then we'll come back. Here's the blue filter removed. Plastic. And here's the CRT itself. I've got the scale lighting hooked up there. You can't see the 3 incandescent bulbs, but you can clearly see where they're located and behind the flange of the CRT there. If I turn it down, there you can see the trace in its natural color. Pretty much the same color as the Gold Star oscilloscope, perhaps a tiny bit bluer. And the CRT is covered in this this thin plastic sheet on the front. Don't know if that has the graticule on it. I think the graticule is printed on the phosphor itself. So I'm not sure what purpose the plastic sheet serves, but it's there. So I'll put the lens back on and then we'll wrap this up. So, I'm actually not going to be keeping this oscilloscope. I have 2 oscilloscopes. I don't need 2 oscilloscopes. I'm actually going to be giving this to Neil, the guy who gave me the Sharp PC7000. He told me that he wished he had an oscilloscope for his workshop, and he wondered if I had one to spare. Well, I did. So I'm going to be giving him this unit, and I hope he enjoys it. I'm giving this to him in return for the Sharp PC7000. And if you're watching this, I've probably already done so, because as of filming this, I'm I'm going to his place tomorrow to deliver it. And I'm also going to check out his electronics collection as well. That should be fun. So yeah, I'm not keeping this thing, but it's going to someone who should get some good use out of it. And that's all I want for pretty much everything that I say, for someone to enjoy it in some way or another. So there you go, guys. I hope you enjoyed this neat oscilloscope, and I will see you later.